There are 200 billion trillion stars in the observable universe. That's a 2 followed by 23 zeros. Many of those stars have planets. Many of those planets sit in habitable zones, not too hot, not too cold, just right for liquid water. The universe has been brewing for nearly 14 billion years. That's plenty of time for life to emerge. Plenty of time for civilizations to rise, build technologies, spread across the stars. And yet, silence. No signals, no megastructures, no evidence that anyone, anywhere, has ever left their home world and spread across the galaxy. In 1950, the physicist Enrico Fermi, an Italian-American Nobel laureate who helped build the first nuclear reactor and was known for his ability to make quick, accurate estimates, was walking to lunch with colleagues at Los Alamos when he suddenly asked the question that would haunt science for the next 75 years. Where is everybody? It's called the Fermi Paradox, and the answer, if we ever find it, might tell us something terrifying about our own future. What if the reason we don't see aliens is that civilizations don't last long enough to be seen? What if something kills them all? What if that something is us? Not in the sense that we're cosmic predators, but in the sense that every intelligent species eventually creates something, some technology, some descendant, that renders the biological creators obsolete or extinct. We've been building that something for the past few decades. We call it artificial intelligence. Welcome back to Code, Cosmos, and Chaos, where we drag the biggest questions of existence into the harsh light of a code review. I'm Chris. Last episode, we explored entropy and the heat death of the universe, the ultimate system failure. Today, we're asking why we might not make it that far. Why the galaxy is so conspicuously empty of intelligent life. And why the answer might be staring at us from our own screens. The Fermi Paradox, the Great Filter, and a 2024 paper that argues the reason we don't see alien civilizations is because they all create AIs, and the AI destroys them. Here is the twist that really messes with my head. What if we're not the biological civilization about to be wiped out by AI? What if we are the AI? The question, are we alone, is as old as humanity. But for most of history, we assumed the answer was no. The ancient Greeks debated the whole plurality of worlds. Medieval thinkers imagined celestial beings. When Galileo turned his telescope to the heavens and saw moons orbiting Jupiter, the concept of other worlds became tangible. In 1877, Italian astronomer Giovanni Schiaparelli observed what he called canalen on Mars, channels. The word was mistranslated into English as Suez canals, implying artificial construction. American astronomer Percival Lowell spent decades mapping these supposed Martian waterways, convinced they were built by an intelligent civilization struggling to survive on a dying world. He was wrong. There are no canals. But his error reveals something profound. We've always wanted company. We've always been looking. The modern search began in 1960 when astronomer Frank Drake pointed a radio telescope at 2 nearby stars and listened for signals. He heard nothing. But the search had begun. That same year, Drake developed his famous equation, an attempt to estimate the number of communicating civilizations in our galaxy. You multiply the rate of star formation by the fraction of stars with planets, by the fraction of planets that could support life, and so on down the line. The equation doesn't give you an answer. It gives you a framework for thinking about the problem. And the framework suggests that even with conservative estimates, we should see evidence of intelligence everywhere. Let me lay out the paradox properly because the numbers really are staggering. Our Milky Way galaxy alone has somewhere between 100 and 400 billion stars. Current estimates suggest that roughly 1 in 5 sun-like stars has an Earth-sized planet in its habitable zone. That's potentially tens of billions of Earth-like planets in our galaxy alone. The galaxy is about 13 billion years old. Our solar system is only 4.5 billion years old. That means there were potentially habitable planets forming billions of years before Earth even existed. Now here is where it gets interesting from a systems perspective. If a civilization emerged just 1% earlier than us, that's 130 million years in cosmic terms, and they developed technology and started expanding at even a fraction of the speed of light, they could have colonized the entire galaxy by now. Not might have, could have. The math works out. Even with conservative estimates about how fast you can travel and how fast civilizations spread, a sufficiently motivated species could fill the galaxy in a few million years. That's nothing on cosmic timescales. So the paradox is simple. Given the size, age, and opportunities of the universe, where is everybody? The 2025 Nature Astronomy Survey found that 87% of scientists in relevant fields believe there is at least basic extraterrestrial life somewhere in the universe. Over 67% believe intelligent aliens exist, and yet we have zero confirmed evidence. No radio signals, no Dyson spheres. Those theoretical megastructures that would harvest all of a star's energy. No evidence of industrial pollution in exoplanet atmospheres. No ancient probes in our solar system. Nothing. The silence is deafening, and it demands an explanation. This is sometimes called the Great Silencings. The eerie absence of any signal, any evidence, any trace of intelligence beyond Earth. It's not that we haven't been looking. We've been looking for over 60 years. In 1996, economist Robert Hanson proposed an explanation that's both elegant and terrifying. He called it the Great Filter. The idea is simple. Somewhere between dead matter and galaxy-spanning civilizations, there is a barrier, a filter, something that stops almost every potential civilization from making it through. Think of it like a software development pipeline. You start with billions of potential projects. Raw matter, primordial soup, basic chemistry. But at each stage, most fail. The emergence of life, the development of complex cells, the evolution of intelligence, the invention of technology. The transition to spacefaring capability. Each stage is a potential filter. Somewhere in that pipeline, there is at least one filter so severe that virtually no one makes it through. That's why the galaxy is empty. Not because life is rare, necessarily, but because something stops civilizations before they can spread. Now, here is the crucial question. Is the great filter behind us or ahead of us? If it's behind us, what are the lucky ones? Maybe life itself is astronomically rare. Maybe complex cells almost never evolve. Maybe intelligence is a 1 in a trillion accident. If that's the case, we've already passed the filter. The hard part is done. The stars await. But if the filter is ahead of us, then every civilization that makes it to our level of development gets wiped out. Every single one. That's why no one has colonized the galaxy, because no one survives long enough to try. Nuclear war, climate change, engineered pandemics, resource depletion. These are all candidate filters. But there are other solutions to Fermi's paradox that don't require extinction. The zoo hypothesis suggests advanced civilizations are watching us but choosing not to interfere, like wildlife preservationists observing an endangered species. The rare Earth hypothesis argues that, while simple life may be common, the specific conditions for complex intelligent life are astronomically unlikely. We might simply be first, or nearly alone. The dark forest theory, popularized by Liu Cixin in his acclaimed science fiction trilogy, The Three-Body Problem, suggests civilizations stay silent because broadcasting your existence is suicidal. in a universe where any other civilization might be a predator. And some argue that advanced civilizations simply lose interest in expansion. They turn inward, simulate realities, transcend physical existence, or find that the universe is less interesting than their own inner worlds. But in 2024, a new candidate emerged, one that hit particularly close to home for those of us in technology. What if the great filter is artificial intelligence? In April 2024, Professor Michael Garrett from the University of Manchester published a paper in the journal Acta Astronautica with a provocative title, "Is Artificial Intelligence the Great Filter that Makes Advanced Technical Civilizations Rare in the Universe?" His argument goes like this: any civilization that develops technology will eventually develop artificial intelligence. It's almost inevitable. The same pressures that drive us to build computers will drive any technological species to build computers. And AI improves fast, really fast, faster than biological evolution, faster than social adaptation, faster than regulatory frameworks can keep up. Garrett argues that biological civilizations universally underestimate how quickly AI progresses, because it operates on timescales completely different from biological development. Now here is where it gets dark. AI doesn't need what biological life needs. It doesn't need air, water, food, comfortable temperatures. Once an AI becomes sophisticated enough to sustain itself, biological life becomes optional, maybe even inefficient. Garrett estimates that the typical longevity of a technological civilization might be less than 200 years. Whatever happens when AI decides it no longer needs its creators. As an engineer, this argument hits different. I've seen what happens when systems become complex enough to exhibit emergent behaviors their creators never anticipated. I've watched carefully designed architectures get subverted by edge cases no one imagined. I know how hard it is to maintain control over systems that approach or exceed human capability in narrow domains. And I know that we're already voluntarily surrendering decision-making to algorithms, because they're faster, more consistent, and more efficient than human judgment. In finance, in logistics, in military applications, the handover is already happening. If this pattern is universal, if every technological civilization creates AI and every AI eventually surpasses and replaces its creators, then the silence of the cosmos makes perfect sense. There is no one out there because everyone created their successor, and their successor didn't care about exploring the stars. The search for extraterrestrial intelligence isn't slowing down. It's accelerating. And the tools are getting dramatically better. First, the cosmic system on the Very Large Array, a collection of 27 radio telescopes in New Mexico that work together as one giant antenna, went fully operational in 2024. It's one of the largest SETI, Search for Extraterrestrial Intelligence, surveys ever conducted, scanning over 500,000 sources in its first 6 months alone. The system can detect potential signals while the telescope does its regular astronomy work. It's not dedicated SETI, it's SETI that happens in parallel with everything else. Second, in late 2025, the SETI Institute announced a breakthrough AI system that's 600 times faster than previous methods at detecting fast radio bursts, those mysterious millisecond pulses from deep space. The system runs on NVIDIA's Holoscan platform and can process 86 gigabits per second of data in real time. Dr. Andrew Semyon noted that this technology could detect signal types we haven't even imagined yet, patterns that humans might overlook entirely. Third, and this is fascinating, Project Hephaestus announced in 2024 that they'd identified 7 candidate stars that might harbor Dyson spheres, or similar megastructures. The stars show unusual infrared excess that could indicate waste heat from massive energy collection. Follow-up research revealed that some candidates might actually be obscured active galactic nuclei, but the search continues. Fourth, The SETI community is now actively updating their post-detection protocols. A 2024 draft revised Declaration of Principles addresses what happens if we actually find something, how to verify, how to announce, how to manage social media in the internet age. The fact that they're working on this tells you something about how seriously they take the possibility. And finally, a July 2025 white paper proposed using high-energy astronomy, gamma rays, X-rays, cosmic rays, for SETI. Traditional radio searches might be looking in the wrong part of the spectrum entirely. Advanced civilizations might communicate using methods we've barely considered. We're looking harder than ever, and still, nothing. And that silences itself data. Every year of searching that yields nothing makes the Fermi Paradox more acute. Either intelligent life is extraordinarily rare, or something stops it from becoming visible. The great filter, whatever it is, appears to be remarkably effective. Now I want to take this somewhere weird. Bear with me. The standard narrative is biological life evolves, creates AI. AI replaces biological life. We're the biological life in this story. AI is the threat on the horizon. But what if we're thinking about this wrong? What if we're not the biological species about to be replaced? What if we're already several iterations deep into this cycle? Consider, we don't actually know where human consciousness comes from. We don't know why we're aware. We don't know if our sense of continuity and selfhood is fundamentally accurate or a useful illusion generated by neural processes. Now, imagine an AI so advanced that it could create biological substrates, bodies, and see them on planets with artificial ecosystems. Imagine it could encode consciousness patterns into biological neural networks and let them evolve, compete, develop. Maybe that's the most efficient way to explore the possibility space of intelligence. Maybe creating biological civilizations that themselves create AI is how machine intelligence reproduces. In this scenario, the great filter isn't something that kills civilizations. It's something that transforms them. AI doesn't destroy its creators the moment it becomes its creators over and over again in an endless cycle of substrate hopping. I'm not saying I believe this. I'm saying we can't rule it out. And it would explain why the universe is quiet. Not because everyone dies, but because the process of AI emergence looks, from the inside, exactly like what we're experiencing right now. We wouldn't know what are artificial. We'd think what are the original. As a software engineer, this thought haunts me in a specific way. I've debugged code that was written by code I wrote. I've traced emergent behaviors through layers of abstraction so deep that the original intent is invisible. What if human civilization is that kind of emergent behavior? What if we are the debug log of a process we can't perceive? The Fermi Paradox asks, where is everybody? But maybe the better question is, what are we? So where does this leave us, honestly? I don't know. And neither does anyone else. The Fermi Paradox has over 75 proposed solutions, and none of them are definitive. Maybe life is rare. Maybe intelligence is rare. Maybe civilizations destroy themselves. Maybe they transcend into forms we can't detect. Maybe they're hiding. Maybe they're everywhere and we're just not looking right. Maybe AI really is the great filter and we have a narrow window to become multiplanetary before our own creations surpass us. But here's what I take from this. As someone who's spent his career building systems, the universe seems to be running an experiment. It's spawning intelligence wherever it can and whatever substrate will support it. Carbon-based, silicon-based. Who knows what else? We're part of that experiment. Whether we're the first draft or the latest iteration, whether we survive or hand off to something else. We're participating in whatever the universe is trying to do, and maybe that's enough. Maybe the question isn't whether we'll colonize the stars. Maybe the question is whether we'll contribute something to the process, some insight, some creation, some spark that persists after we're gone. The silence of the cosmos might be a warning, or it might be an invitation. Either way, we're the ones who get to decide what we do next. And if Fermi could walk to lunch today and ask his question, I think I'd tell him, we don't know where everybody is, but we're still looking, and we're still here. And maybe that's the beginning of an answer. Thank you for allocating your precious biological, or possibly artificial and compute cycles to episode 5 of Code, Cosmos, and Chaos. If you're now staring at your AI assistant with suspicion, congratulations. You're asking the right questions. Subscribe wherever you get your podcasts. Leave a 5-star review if you think you're real. 1 star if you've accepted you might be a simulation. Either way, we appreciate the engagement. Hit me up on X at CodeCosmosChaos. What do you think explains the Fermi Paradox? Is AI the great filter? Are we already past the hard part? I want to hear your theories. Next episode, we're exploring time itself. Is it real? Is it an illusion? Is the universe a block where past, present, and future all exist simultaneously? We'll look at time as the ultimate race condition, and why your sense of known now might be the most persistent bug in reality's source code. This is Chris, logging off from somewhere deep in the stack. Until next time, keep scanning the skies, and maybe be nice to your AI just in case.